He was a successful inventor and engineer. He was a modern polymath who left his mark on the history of sciences. The development of microscopes is closely related to the development of modern sciences. The examined object was lit by a scotoscope. The polymath considered himself an observer biologist, is directly proportional to the magnitude of the force that causes the change. It was invented in the second half of the 17th century simultaneously by William Clement. The leaders of the city asked Hooke to participate in the reconstruction of London. He designed various public buildings, e.g. the Bethlehem Royal Hospital, and many others together with Wren. At the age of 16, he started to work in a cloth shop in Amsterdam. Unfortunately, only 10 of them survive to this day. His microscopes were capable of magnifications of up to 270x. Red blood cells do not have a nucleus. Their cytoplasm contains hemoglobin, which binds oxygen. Robert Hooke was born into a poor family in 1635 in Freshwater, Isle of Wight, England. Being a sickly child, his parents refused to send him to school. He enjoyed observing nature and building small mechanical devices. Moreover, he was talented in arts as well. Hooke's scientific work is very diverse. He was a successful inventor and engineer. Microscopes, lens polishing machines, clock mechanisms, telescopes, barometers, etc., and a renowned scientist, biology, chemistry, physics, astronomy, geology, etc., at the same time. Some scientists consider him the English Leonardo. Undoubtedly, he was a modern polymath who left his mark on the history of sciences. An asteroid, a crater on the Moon, and another on Mars, as well as a medal awarded by the British Society for Cell Biology, were named in his honor. Microscopes are instruments that can be used to observe small objects invisible to the naked eye. The development of microscopes is closely related to the development of modern sciences. The first microscope was probably built in the Netherlands at the turn of the 16th and 17th centuries. Hooke's microscope had a very simple structure. He placed the eyepiece at the top of the barrel, while the objective was found at the bottom end. The examined object was lit by a scotoscope. The microscope designed by Hooke and published in Micrographia was built by Christopher Koch, a craftsman from London. His microscope was made of wood, covered with leather on the outside and decorated with gold. Currently, it is exhibited at the National Museum of Health and Medicine in Washington, D.C. Hooke made lots of observations using the microscope he had designed. He studied mainly the anatomy of plants and animals at microscopic level. The term cell was also invented by him. Thanks to his talent in arts, his observations were illustrated with extremely detailed drawings. In 1665, he published his most significant work entitled Micrographia, or some physiological descriptions of minute bodies made by magnifying glasses, with observations and inquiries thereupon. This was the first printed book in the history of sciences with a large number of colorful illustrations. This book is a good example of Hooke's clear and easily understandable style. Therefore, it is no surprise that the publication quickly gained popularity and made the author famous outside England as well. The polymath considered himself an observer biologist. Hooke's law is an empirical law. It states that the change in the shape of an elastic object is directly proportional to the magnitude of the force that causes the change. Expansion is inversely proportional to the cross-sectional area of the object. Hooke's law can be expressed with the following formula. F equals d times delta L, where F is the applied force, vector quantity, d is the spring constant, characteristic of the elastic material, and delta L is the deformation, change in the length of the elastic material, a vector. Hooke's law can be used to describe the linear motion of springs. The elastic force exerted by the spring is directly proportional to the change in its length and is opposite in direction. The invention and further improvement of the anchor escapement was an important milestone in the history of horology. Its name is due to the fact that its shape resembles the anchors of ships. It was invented in the second half of the 17th century simultaneously by William Clement, a clockmaker from London, and Hooke. The anchor escapement is a mechanism that keeps the pendulum swinging through the movement of the anchor wheel, ensuring the continuous movement of the clock's hands. The pendulum must be pushed to start the cyclically repeating motion. The mechanism consists of two parts: a vertically positioned anchor wheel equipped with teeth and an anchor swinging back and forth on a pivot. Hooke's artistic talent was used not only in sciences but in other areas as well. While studying at Oxford, he met Christopher Wren, who had been commissioned by King Charles II to rebuild the city of London after the Great Fire of 1666. The leaders of the city asked Hooke to participate in the reconstruction of London. Hooke, together with his friend, played a key role in urban planning and designing the cityscape. He designed various public buildings, e.g. the Bethlehem Royal Hospital, and many others together with Wren, e.g. Monument to the Great Fire of London. Antonie van Leeuwenhoek was born in 1632 in Delft, Dutch Republic. At the age of 16, he started to work in a cloth shop in Amsterdam. In 1654, he returned to his hometown and got married. He opened his own cloth shop. He learned how to polish lenses. He started to use microscopes because he wanted to confirm the quality of the materials fibers he sold. He admired Robert Hooke's micrographia, which encouraged him to perform experiments. Thanks to his determination, he became a great zoologist. The Dutch zoologist is considered the father of microbiology. A crater on the moon, an asteroid, various scientific awards, a bacterium genus, several plants, and a hospital in Amsterdam were named after him. In a public poll held in 2004 in the Netherlands, De Grootste Nederlander, he was chosen as the fourth greatest Dutchman. Robert Hooke's micrographia inspired Leeuwenhoek to study bacteria. Initially, he used Hooke's microscope, but later, he preferred to use the microscope designed by himself. Leeuwenhoek built about 500 microscopes. However, unfortunately, only 10 of them survive to this day. Leeuwenhoek's instrument, a tiny lens secured between two copper plates, can be considered a simple microscope. He held the device close to his eyes to study the object attached to a pin. The sharpness of the image could be adjusted with screws. The use of his microscope required good lighting and a lot of patience. However, the quality of the image it produced was better than that of other microscopes of the time. Moreover, its field of view was also wider. Lenses for his microscopes were polished by himself. His microscopes were capable of magnifications of up to 270x. He was the first to study red blood cells, unicellular organisms, bacteria, and sperm cells. He observed the blood flow in capillaries, the striated appearance of skeletal muscle fibers, and ciliates in still waters. He can be considered the founding father of microbiology. Red blood cells do not have a nucleus. They measure approximately 7 micrometers. Human blood contains 4.5 to 5.5 million red blood cells per cubic millimeter. Their cytoplasm contains hemoglobin, which binds oxygen. The invention of the microscope not only transformed science but also opened a new lens to view the world, both literally and figuratively. If this story inspired you, imagine the countless discoveries waiting to be explored. Help us bring these stories to life by hitting that like button, sharing this video with your friends, and dropping a comment below about what amazed you most. We're on a mission to make learning fun and accessible, and your support makes all the difference. So, don't forget to subscribe to 3D Learning Lab and turn on the notification bell to never miss a journey through history, science, and innovation. Follow us on social media for updates and exclusive content. We're just as passionate about learning as you are. Together, let's spark curiosity and inspire minds worldwide. Thank you for being a part of this journey.